promoter of Magma Research and Consultancy Service India, for the next technical session on advanced topic on DL-RNN, autoencoders and transformers. Dr. Gaurav Kumar is a founder, director and first promoter of Magma Research and Consultancy Service India. His qualification integrates MCA, MPhil, MTech, PhD, LLB and IBM Certified Associate Developer. He possesses more than 20 years of experience in teaching, industry and research. The article and research papers on assorted technologies published by him as main author in international magazines, journals, newspapers and conferences. He is associated with number of international periodicals as editors, reviewers and member of advisory panel. Welcome you, sir.
Good morning, ma'am.
Good morning, sir. Over to you for the technical session.
Okay, thank you, ma'am. Good morning to all participants. And now we are starting this session. Kindly confirm, is it audible and visible?
Yes, sir. Yes, sir. You're completely audible and the slides are visible.
Okay. So in this session, we will discuss about some advanced tools, advanced algorithms for deep learning, including recurrent neural networks and along with this particular domain, that is recurrent neural network implementation, we will discuss about some scenarios of real world data analytics using LSTM, that is long short-term memory. And after that, we will see by which way we can use transformers for natural language processing, in which we will cover implementations of Google search, which particular algorithm is working at the back end of Google search. Whenever we type something in Google, so it gives us suggestions automatically during typing on Google search text box. We get some suggestions. So we will see which are those deep learning based models by which we get some suggestions. And this domain is covered under natural language processing and transformers, PyTorch transformers. And then we will see with some practical hands-on how to work with autoencoders, compression of data set in deep learning. So first of all, we will start with recurrent neural networks. With each and every implementation that we will perform, first of all, we will see its concept, its paradigm, by which way it works in layman's language, in very real world examples, and then all implementations will be performed in Google Colab. And before end of this session, I will share each and every source code and study material presentations. So now we will see what is basically an RNN, that is recurrent neural network, and in which particular domain it is used. When we are having some sequential data, so in previous session also we have discussed it briefly. When we are having some sequential data, temporal data, time series based data, and on basis of the historical data or current data that is temporal in nature, that is of type temporal database or sequential. Sequential means the data that we are collecting in real time or in multiple time spans. If we discuss about one simple example of current scenario, I think everybody might be aware with a specialized device nowadays, that is Alexa device. Nowadays it is very popular for home automation. If I want to switch on or switch off my home appliances, if I want to power on or off my LED, washing machine, AC, so we give some instructions. Okay, Alexa, do this task. Alexa, power on AC. Alexa, power on this smart TV. Power off this particular device. So this is also sequential data. It is also temporal data. Google voice search, when we say something, deliver our audio to Google search. So it automatically detect from a series of some particular vocabulary. So Apple Siri is also another assistant, smart assistant. Many of you might be using Amazon Fire Stick. Nowadays, some special Fire Sticks are available that look similar to remote, and we can make our TV, traditional TV, to smart TV. So what is the technology behind these implementations? So when we say something, for example, I'm saying something, okay, Alexa, open YouTube, Alexa, open Netflix. For example, at that time of saying something, my audio is fumbling. It is not clear. Rather than saying YouTube, the tongue fumbles. YouTube or YouTube. So because each and every person is having its own vocabulary, its own pronunciation, and in everybody's pronunciation, the delivery of text, delivery of audio may be different, and it's different definitely. If a particular sentence will be delivered by some American accent, it will be different. In British accent, it will be different. In any other language, in Hindi also, in different other languages also, accent or the delivery of audio differs. So RNN is that specialized implementation in which sequential data is analyzed. Data that is sequential in nature, it checks, okay, what is meaning of this? If I write something on Google, okay, what is meaning of? Now I'm opening Google just for explanation. So you can see, for example, I'm writing here like what is meaning of. Now you can see that I'm not writing anything else. I have simply written only what is meaning of. So it is giving me suggestions. So what is this? This is also sequential data. It is also sequential. So it is checking what I mean to say, what I mean to write. Okay, where is? So where is? So it will check. It will give me suggestions depending upon current scenario. What I want to ask. What is the probability of asking a particular word? Okay. So what is this? I have written only this, but it is giving me its upcoming words. It is giving me, it is suggesting me some sequence of upcoming words. What is this? This is implementation, or this is a real world example of recurrent neural network, and at backend of which we make use of transformers. So we will see that also in practical. We will see it by Python coding. So how to fetch some real time data using Python with the backend of Google algorithm. So we will link the algorithm or pre-trained model of Google, and then we will see whether it is giving same output or something different. Now, if we come again to our this part, recurrent neural network from historical data. Now, which are different examples of recurrent neural networks? So this is one example, Alexa device. I'm saying something and it is automatically detecting. It is automatically checking what I mean to say. And definitely that Alexa device must be trained. That is also deep learning implementation. For example, I have not trained any data in that Alexa. It will not give good results. If I will not show my home scenario, if I will not give training data, okay, at this location, there is refrigerator, at this point, there is this point, there is some particular device, there is some home appliance. So I will have to give that particular data for training in that deep learning model that is working at the back end of Alexa. In case of Amazon Fire Stick, it is already trained. If we want to open Netflix, YouTube, or whatever channel we want to open, so it is already trained. Okay, what we want to say, and to which backend library it should be linked. Okay, so recurrent neural network is one of the key part, and it is required in most of the real world applications. So this is one example of searching Google search or Alexa devices or Apple's Siri. Apple Siri is assistant, smart assistant similar to Alexa. Now, which may be another example. This is one scenario. Okay, search. We are saying something. Second scenario. In case of another example, there is prediction of financial data.
गौरव सर हम लोग स्लाइड फर्स्ट पे ही अभी है ना?
Yes, sir, it is first slide. We are explaining the concept.
मुझे लगा कि कहीं ऐसा तो नहीं कि स्लाइड नहीं चेंज हो रहा हो.
No, it's we are discussing the concept and then we will move ahead, sir. Okay, so second example, second scenario of RNN, that is stock price prediction. You might have seen that there are number of implementations, number of scenarios available nowadays where we can give historical data of a particular stock. For example, I want to predict stock price of SBI's share, and in sequence. So one way is that, okay, I want to predict today, okay, what may be the output today, what what will be the opening price of SBI, what will be the price of stock of Reliance today. That is one scenario, okay, single value we want to predict. It will be considered as a regression problem, because stock price, share price can be anything. If I want to predict price of Ethereum, Bitcoin, Dogecoin, or Stellar, that is one point, okay, regression problem, because in the case of regression, a specific value is predicted. But if I want to predict a series of predictions, series of values, like series of price of Ethereum, series of different prices of Bitcoin in 1 month, day wise or second wise or minute wise, what will be the diversion? That is also scenario of RNN. Stock price prediction, prediction of some disease, prediction of some particular disease. For example, I'm having my historical X-rays from last 5 years. I want to predict upcoming X-rays. Okay, if this particular tumor is getting developed in this way, then what will be the size of tumor after 5 years, or in a sequence? What will be the diversion in that image? In which way I will be looking after 10 years, after 20 years? What will be my image face value? Now we will see how it is possible, which technologies or which algorithms work at the back end of RNN. And as you can see here in this slide, RNN integrates two major parts, two major segments, LSTM and GRU. LSTM that refers to long short-term memory, and GRU, that is your gated recurrent units. One more thing that we should be clear, that when we implement RNN, it is never implemented alone. Inside RNN, either we will use LSTM or we will use GRU. I'm repeating this point. Whenever we have to work on some sequential data, we have to implement one of these two approaches, either LSTM or we use GRU. So in this, the type of network or the diagram, okay, LSTM. So inside RNN, LSTM or GRU works. The performance of RNN will not be good without one of these. If we try to implement RNN independently without LSTM or GRU, then performance will not be very good. Why? What is basically LSTM and GRU at backend, or what is the role of these two units, these two modules? In very simple way, we can say that these two parts, LSTM and GRU, they act as catalyst to the recurrent neural network. They act as catalyst that improves the performance of network, that provides parallel computing, parallel implementation. These two units are used for load balancing in RNN. If we will implement RNN independently, in that case, its performance will not be very effective. But if we will integrate LSTM inside RNN or GRU inside RNN, then performance of RNN will be increased. So you can see here, this is the diagram. So in layman's point of view, you can see that, for example, some production unit is there. Okay, we are relating it to some production unit. In that particular production unit, these are different pipelines. What is this? These are different pipes. With each and every pipe, you can see that with each and every pipe, there are some points, there are some levers. So these are different levers associated each and every line. When we move to some power plant, thermal power plant, or electricity station, or some production unit. So you might have seen that whenever there is huge huge delivery of data, sequential delivery to stop any particular unit, to stop any particular pipeline, there are some levers associated, and it happens everywhere. You might have seen this in case of in railway stations also. In railway stations, you might have seen that there are so many pipelines of water, and after some distance, there are some levers associated. So we can stop the supply anytime. In homes also, in home appliances also, that we call as meter, we implement it. It is implemented by electricity department. Okay, this MCB up, this MCB down. What is that? If we automate it, it becomes RNN or recurrent neural implementation with LSTM and GRU. So that is the automated version. LSTM and GRU is the automated version of switch on, switch off of a particular supply. If there is no switch on or off of a particular supply, then you can imagine it may be a blunder. There may be information loss. In case of computers, in case of IT, there will be information loss. In case of power plant, it will be loss of power supply or overloading of power supply or burst of power supply. In case of water, water tank, it may be the burst of water, and definitely it is not required. So these are the diagrams. In case of LSTM, now the question comes, what is major difference between LSTM and GRU? And one more thing we should be clear. So one point is that inside RNN we have to use either LSTM or GRU. Second point, in case of inner layer of RNN, these two are not implemented in hybrid way, either LSTM or GRU. Okay. So we should avoid using both of these at a time. And what is major difference between LSTM and GRU? So you can see that in LSTM there are three gates, input, output, and forget. Input, output, forget. It means a single line of information is having multiple links, multiple levers, input, output, and forget. Forget means if that information is not required, it will be pushed back. In case of GRU, there are two gates, update or reset. Okay. But we have to see which type of implementation we should use, well, whether LSTM we should use or whether GRU we should use. So it depends on the data set. If data set is small, for example, very small data set, sequential data, and that sequential data is, for example, 1000 tweets per minute, in that case, GRU will be okay. If we are getting 1 million messages per second, per minute, then GRU cannot be implemented because we need multiple units, multiple switches, power on, power off, to switch on, switch off. Okay. So for small data set, for small size of pipeline, small size of information, we have to use GRU. In case of huge data, for example, we are working in big data in RNN, then we should use LSTM. Okay. LSTM is providing more load balancing. It provides more flexibility of information dissemination and its analytics. Is this point clear to all of you? What is major difference between LSTM and GRU? Is it clear to all? As far as concept is concerned, is clear to all of you? Kindly confirm or any query in this part so that we can move ahead to the implementation. We will see its implementation in Google Colab. Okay. Now we will see this. I'm opening Google Colab so that we can see its implementation. And for this, first of all, we want to see what is our data set. Now you can see this. This is the data set that we will use here. It is the data set of stock market. You are working in, or you are aware with stock trading, then you might be knowing this fact that in this way there is data set of some particular stock, opening date of some particular share, high, what is the day's high value, day's low value, and at which particular value, at which particular price that stock closed, and how much volume was there, how many shares were sold or purchased. It means how many shares, number of shares were traded in that particular day. So, for example, so this is the data of a particular stock, and day wise its analysis is given. Day wise its values are. This data is up to, you can see that thousands of records are there in this particular data set. Okay. You can take this type of data from multiple sources, from Yahoo Finance. You can download this particular data. If you want to work on blockchain based environment and I want to predict next year's data or next month's data in day wise pattern about Bitcoin, Ethereum, Stellar, or Zrex, whatever it is, we can download it and we can predict in regression mode. We can analyze. Okay. Now this is the data, and this is the training data. You can see that it is the training data, and depending upon this training data, now you can see that it is sequential data, day wise, 1st March. Okay. 1st April. It is day wise or week. So it depends on the data set, whether it is day wise data, weekly data, monthly data. Okay. But whatever this data set is, whether weekly, monthly, second wise, minute wise, but in actual, it is sequential data. And in case of sequential data, we must use RNN. In this case, we should use, must use, no, we should. We must use RNN. I will try to implement CNN here. The results will be very bad. Results will be approved. Even if I get 99% accuracy, but that accuracy can be challenged by people. Anybody can say that how to implement CNN is not suitable. This is time series data. And such type of data sets are available on IEEE data code. IEEE data code, and this is another source that Mendeley.
हेलो
Yes, ma'am.
सर सॉरी टू डिस्टर्ब यू आपका ना वॉइस बहुत ज़्यादा ब्रेक हो रहा है
Okay. Is it clear? Just a minute. I'm unmuting. Okay. Is it audible, ma'am?
यस यस सर
Okay, ma'am. I'll try to improve audio quality. So you can see that stock market data. So you can see that stock market data of multiple cities, and in this also you can see here in metric.com data sets are available. Okay.
ये
Is it
तो
audible?
मेरे
Is
को
it
पता
audible now? Is this audible now, ma'am?
यस सर
Stock market. For example, I want to get data about a particular crypto and I want to predict it. So it can be taken from Yahoo Finance. Okay. Historical data. For example, Stellar XLM. XLM is the code. So you can see Stellar USD, in which pairing I want to analyze it. Okay, so you can see that day-wise data is available. Is this visible to all? So day-wise data of cryptocurrency Stellar. In same way, you can take data of Bitcoin. So same data I have taken in this Excel sheet. Now, depending upon this particular data set, I want to predict the upcoming pattern of this crypto. Then one way is that I will use traditional machine learning. But in traditional machine learning, results may or may not be good. Results may be compromised. Accuracy may be compromised. But if I will use recurrent neural network, and inside that we will use LSTM, performance will be very, very good. Okay. Now, so this is the training data, and what is my testing data? This is my test data. And now you can see that I want to predict. Okay, so opening, I don't know what will be the opening price, so I can put any date. Okay, so each and every value I have put here 0 because I have to predict it. Okay, opening 5, I want to predict these values. What will be the opening price, high, low, close, or what will be the trading volume? However, it may or may not be possible. It may or may not be giving good results, because everybody knows that crypto or stock market, these are very, very much manipulative markets. Still, using some algorithms, using LSTM, we can do it. Now you can see here, this is the scenario of LSTM, and I will show you this source code, and at end of this I will at end of the session I will give you this code also. Okay, now you can see that this is LSTM implementation, and we will understand this code line by line. Is it audible and visible clearly? Kindly confirm. Recurrent neural network with LSTM in inner layers. Okay, is it audible and visible to all? Kindly confirm whether audio quality is okay.
Yes, sir.
Okay, now you can see that in Google Colab, we will run this code and I will see, okay, we have integrated GPU here. So you can integrate TPU also, no issue. So from google.colab import files and files.upload. Using these two lines, your data set will be uploaded. Okay, now this is my training data. So for training, I'm using this Google stock price train.csv file. This is the train.csv file. It means I will train this particular data. I know historical values. I know historical data set of this particular stock. That is sequential, that is temporal, that is in time series mode. Okay, and so I have integrated it, and now we will see that feature scaling. This is the major part that we should understand, that we must implement standard scaling. If we do not use scaling or pre-processing in deep learning or machine learning, then also results will be very, very bad. We should be clear about it. Whether you are implementing traditional machine learning or deep learning on images, deep learning on text data, feature scaling or pre-processing is mandatory. If we do not use feature scaling, if we do not use pre-processing, min-max scaler, if we do not use this type of approach, then results will be very, very bad. Why we say that it is required, it is mandatory? If I open this Excel sheet, you can see that, for example, some particular stock value. Okay, so if I train this particular data, you can see that some values are very, very high. So this particular value, 41,25,300, this is very high value, but its opening price is very, very low. Its closing price is very, very high. Okay, but if I do not use standard scaling or min max, then what will happen? Whatever attribute is having high value, it will dominate the entire prediction. For example, I am training my data set. I am training my model with these 5 values. One value is 302. 302 is only 302, that is 3-digit number. This is also very less number. Okay, but 604 is almost double of this. It means highest preference by deep learning algorithm will be given to this value, because deep learning don't know whether it is opening price or closing price. It will see the value. If I'm training this value also, if I'm training trading volume also, then first preference will be given to trading volume, and in that case it will be biasing. It will be biasing of results, biasing of the outcomes. So to avoid biasing of the outcome, to integrate the equalization, it means equal preference should be given. My deep learning algorithm, whether LSTM, GRU, it should give equal priority to all. But if I'm giving this value in training without min max, in that case highest preference will be given to this and minimum preference will be given to this. If we take any other example, for example, this value 303, okay, this 282, and this is also almost double. So to avoid it, we have to scale down. Scale down means each and every value should be in same range. So what min max do? Min max, so I'm opening notepad for explanation. So min max reshape all values in a range. For example, this 286, it will become 0.3. Each and everything will be in a specific range of 0 to 1, so that there will be no biasing, there will be no favoritism. 288 will become 0.2. Okay, 285 it will become this, and this 505782 it may become 0.8. So every value will be in same range. In same way, 289 may become 0.12, 112. Okay, it may become this. Another value can be this in this way. So that's why. So whether you are using X-ray data or you are using satellite data, min-max scaler must be implemented. Feature range 0 to 1. It means every value will be converted to a particular value in this range only. Otherwise, you can imagine, for example, we are having diagnosis data. We are having data set of patients, and in data set of patients, I am having age. Okay, whether it is diabetic or not. Okay, Aadhaar number, and died or not. If I am specifying this value, okay, 23, not diabetic, Aadhaar number, 12-digit number, whatever it is, and that person not died. If I train this model, then highest preference will be given to Aadhaar number, and its results will be very, very bad, because this is very large value. This is long double value, and minimum preference will be given to diabetic because it is only single digit number. But using min max, 23 will become 0.1 or may become 0 as it is, and in this way every value will be confined to a specific range. So that's why we use it. Okay, and now we will see LSTM part. So from keras.layers, we have imported a dense network, and inside that we will use LSTM and dropout. This is also mandatory. Dropout is also mandatory. I will explain it. Okay, so you can see that we are initializing the RNN. Sequential model we are taking. Why sequential? Because in last session also we have seen that input layers, some particular inputs, then hidden layer, then output. So it is in sequence. And this is the name of model, regressor. Why regressor? Because we want to generate a series of values. Okay, and regressor dot add LSTM units is equal to 50. So any value you can specify. There is no thumb rule for that. Okay, and what is the input shape? Training data, and dropout 0.2. It can be 0.21, it can be 0.3, it can be 0.22. Generally, we take dropout of 0.2. Whether you are using GRU or we are using CNN or DNN or LSTM, this is required dropout. What is meaning of dropout? Dropout means 20% out of 1. This is 20%, and dropout 20% means 20% records will be skipped randomly for better training. In each and every layer, 20% records will be skipped. Now you can see that if I write here dropout 0.3, then out of total records, for example, I'm having 1000 records. At the time of training, 30% records, it means 300 records will be removed automatically, and then model will be trained. Okay, I'm using 20%, then out of 100 records, 20 random records will be removed at the time of training to avoid overfitting. If we do not use dropout, without dropout, model may be overfit. So randomly it will drop some values. If I'm using 0.1. So it is not advisable to give 0.1 because 10% records skipping is very, very less. So we should take 0.2, 0.25, 0.3. Okay. Any of these value you can take. So in each and every layer, you can see that dropout is taken. Or what you can do, for example, here 0.3, then 0.2, then 0.2. Okay. In each and every layer, we use some dropout to avoid overfitting. And after that, we are training this model. You can see that compiling with Adam optimizer. So Adam, NADAM, ADAMX, different optimizers are there. And in which and how many number of epochs we want to take, 10 number of epochs. What is the batch size? 32. And then we will predict for the upcoming stocks. Now I am executing this code and I will upload the data set. First of all, I am uploading this training data. Okay, train.csv. Okay, so first of all, we should be having good data set, suitable data set. After that, we perform pre-processing. After pre-processing, we use RNN with LSTM. Along with that, we use the dropout value. Okay, so you can see that multiple layers and then dropout. And you can see that its epochs are running, and we will see that how much loss. You can see that loss is very, very less, and we can take it. So I'm uploading to both of these files at a time, test data and this train and test. So this is Google stock price prediction. So rather than Google, you can take State SBI, Reliance, or any particular cryptocurrency on which you want to make predictions. So loss value is very, very less. Okay, and you can see that predict what is the real stock price. What is my actual stock price? 00. In test data, it is 000 because I don't know what will be the sequential data, upcoming sequential data, and this is the prediction. This is the prediction. So on first date, whatever we have specified here, its value will be this 810, 809, 803. So these are predictive values. Okay, so and you can see that how much it is easy. Generally, scholars or researchers in this domain of deep learning, they think that deep learning or LSTM, GRU are very, very difficult, but these are very simple as compared to traditional machine learning. It is simpler than traditional machine learning. Okay, so you can see that. So we can see its prediction. If I modify the dropout value to 0.3, then also its value will be changed. So definitely prediction will be changed. Prediction will be different if you will use any other dropout value. Okay, so you can see this 0.3. What will happen in 0.3? So first prediction is 810 in 0.2. First is 810 in 3. We will see in this we will see what will be the price, train and test data. So in previous 20% dropout, it was 810, and in 30% dropout, we'll see will it change, whether prediction will be different or it will be same. Definitely prediction should be different. Now if we run this, now you can see that in 30% dropout, it is 762.79. Okay, so we can work in this way. I'm copying this code. I will share this source code to all of you at end of the session. Up to this point, is it clear to all? Kindly confirm in chat. Is it or by audio also you can confirm? Is it clear to all of you how to implement LSTM for prediction of upcoming data in sequence? Is it clear to all? Or any point of discussion, any query you can ask in this implementation? And is it audible and visible to all in clear way? Kindly confirm, is it audible and visible to all, and up to now it's clear or not? So should we move ahead to next topic? Is it audible, ma'am? Kindly confirm. Organizing team, kindly confirm. Is it audible and visible to all? So now we will come to next part, next topic, that is transformers. Is this presentation visible to all of you? Presentation and audio clear to all? Kindly confirm. Is it clear? Kindly confirm whether you are able to view this presentation. Organizing team, ma'am, kindly confirm. Is it clear to all? Are you getting this screen and audio clearly?
Yes, sir.
Okay. And any message from any chat message from participants about any query till now?
Not yet, sir.
Okay. So
Sir, there are some hands which are raised for the query. Can I ask? Can I allow them?
yes, ma'am. Or in last 15 minutes we will take
Yeah.
the.
Okay, sir. ठीक है, sir. We will take the queries in last 15 minutes.
Okay. And now we will cover the, first of all we will cover all topics as per the schedule, and in last minutes we will discuss about your queries. And this is the another very important segment in deep learning, that is transformers. Very powerful implementation, and using these transformers we can work on the algorithms which Google has developed. Whatever algorithms Google has developed for its search, we can work on those. For natural language processing, for text analysis, for prediction of upcoming data. And in this scenario of transformers, we will see how to use pre-trained models. So you can see that This is the URL, that is Hugging Face. It is a repository of AI models with specialized reference to natural language processing toolkits. And all of these are available in free and open source distribution. So, for example, you want to work on an algorithm that Facebook is using. I want to use that algorithm in my implementation, which is used by Microsoft. So you can see that Facebook wave to vector. Okay, and in which segment we want to work, you can see that models. On click of models, different hundreds of models are available. You can see for text generation, for text classification. Thousands of models are available here with source code in multiple programming languages. You can see here, if I want to work with PyTorch, that is available. If we are working on an algorithm with TensorFlow coding, that is available. If I want to work with BERT, so what is the model? So BERT is that algorithm. BERT is that deep learning model that is used by Google for its search, for scanning different websites, even for search engine optimization also, to check whether this particular page should be on first page. For example, you have developed your website, okay, and you want to make you want to work on search engine optimization, digital marketing, and you want that if somebody write top engineering college in Ghaziabad, you wish to get your web page on first page of Google. So BERT will decide, BERT algorithm will see, it will check the content, it will check search engine optimization parameters, and then it will push it to first page. Okay, BERT GPT algorithm. So many approaches are available. Data sets are also integrated in this: acronym identification, adversarial QA, and so you can see that in different domains these are available. Okay, BERT large cased, BERT uncased. So BERT, what is BERT base uncased? BERT base uncased is that transformer. These are basically transformers. It is that transformer which check whatever you are typing in Google, what should be the next word, what should be the next sentence. For example, I want to write one paragraph from single sentence. BERT can do it. Text generation, text transformation. In research, you might have heard about of spinning, paraphrasing, content spinning, content paraphrasing, content quilling, that is used to change the paragraph in another paragraph. In that case also, these deep learning models are used, BERT based. So we will see it. Okay, so this screenshot I have put, and these are the links. So you can see here .co and BERT. Okay, or here BERT base uncased. So we will see its implementation, we will perform it, and you can see here at backend of BERT there is RNN, there is recurrent neural network. You can see that this RNN is working in that. Updated RNN, improved RNN, and now we'll see its different models. One is BERT approach, and it is under the copyright of Google. But nowadays it is available for public domain for research. If you are doing research in natural language processing in NLP, you can use BERT algorithm. It is developed by Google. If you want to work on GPT, that is generative pre-trained transformer, then it is released by OpenAI. Okay, XLNet, XLM. If I want to work on cross-lingual language model training and the algorithm that is used by Facebook, I will use XLM. Okay, transformer, XLNet, these are delivered by Google. BERT is also under control of Google, but researchers can use it. So using BERT, using GPT, you can create your own devices. You can create a device similar to Alexa, similar to Fire Stick. You can create your own language generators. Okay, and first of all, what we have to do to work on transformer, to work on these transformers, BERT, GPT, GPT-2 transformer, these are available in PyTorch in this package. Pip install PyTorch transformers. So in Google Colab or in Kaggle kernels, we have to install this. Okay, so I'm opening this in file, and we can use that. So we are working on transformer, and we will connect. So first of all, we will have to execute the instruction to work on this package. So first of all, we have to install it. Pip install transformers. Okay. I will click here so that it will be reinstalled, because last time it was installed and now it is wiped out. And you can see that. So you can see that it is available on this website, Hugging Face Hub and PyViYAML. Pip install this, and now you can see this BERT. From transformers, import BERT model. We are importing the BERT model. Okay, so we have to integrate it, and its functions are available here in this website of huggingface.co. Okay, it is BERT base uncased. BERT base uncased means case insensitive, no case sensitive. Whether if I'm typing something like what is name of W capital or W small, uncased. Okay, no issue of any case. And we download the repository. And after that, automatically the backend vocabulary will be integrated, and then we have to install this sentence piece and PyTorch transformers. Okay, PyTorch transformers. So we have installed it. Now you can see that this is the code of GPT, and after that we will see the BERT. Okay, GPT tokenizer. So from PyTorch transformers import GPT to tokenizer. What is GPT? This is GPT, generative pre-trained transformer. Okay, so you can see that if I'm typing something, what is the name of, so any name, or what is the fastest car? For example, I am writing here in the, I'm not writing anything after in the. So you can see that first suggestion, it is giving me world 2021. Okay, now I want to predict it. I want to perform it practically. I want to perform it in Python. So you can see that I have written here in same way. I have written what is the fastest car in the. Now using GPT pre-trained model, I want to see what it will show in the world or in India. Okay, and then we will match it. We will execute it, and after running this code, and you can see that each and everything we are putting to CUDA. So token tensor to CUDA. CUDA means we are running it on that GPU device, and here we have written only this. What is the fastest car in the? Now I want to see, it is giving me prediction what is the fastest car in the world. In actual also it is giving me in the world. Okay, so I have not written here in the world, but using that GPT model. So now I want to see anything else. What is name of the richest? Only this. What is name of the richest? Okay. Name of the richest. We want to see, or Cato. Now I'm not writing anything. It is giving me first suggestion that what is the Cato diet. I want to see it practically. What is the Cato? Only this part. And on running of this, I want to see what it will show next word, which next word it will predict. It is showing me what is the Cato diet. So using GPT model, using GPT based transformer, we can check it. Okay. Of the richest or poor, whatever it is. Okay, richest. What is the name of the okay, what is the name of the only this we are doing, and now we'll see what it will predict. What is name of the what is name of the game? So if I will type it in Google, then it will give this prediction. What is the name of Olympic? We will see what it will show next after that word. Olympic champion. If I will write this keyword in Google, then we can check it. Olympic champion. Okay, so using PyTorch models, using pre-trained transformers, we can work on this segment. Okay, so you can see this GPT-2 tokenizer from pre-trained. Which pre-trained model? GPT-2. This is the version. Okay, in same way, now you can see that how much it is easy to work with it. For example, I want to see something that using BERT model. So you can see that I'm using BERT model. From transformers import pipeline, model is equal to BERT base uncased and hello, I am a mask. Mask means I want to predict it. Mask means fill in the blank. Now I want to see what Google will show me if I execute this. What will be the prediction of Google in place of mask? Mask means this is fill in the blanks. Okay. Hello, I am a fashion model. This much score. It may show me I am a role model. It may give me result I am a supermodel or I am a fine model. So scoring of different things. Now if I want to see that hello, okay, mask and champion. I want to see what it will show me in this. Mask means fill in the blanks. So Google will fill in this particular blank. Fill mask. Google algorithm will be used for fill in this particular blank. I am a mask champion and I am a champion, I am the champion, I am world champion. It may give me I am my champion, I am your champion. Okay, and scoring of each and everything. What is score of I am a champion? I am a, if I'm writing I am a, then what it will show? I am a mask means fill in the blank. I am a world champion, great champion, national champion, chess real. Okay. I am participating in mask. It will predict what value should be here using BERT algorithm of Google. Using only these 3 lines, only in 2-3 lines of code, we can import Google code, Google algorithm. So I'm participating in Olympic Games, in Paralympic Games, in these games, in Commonwealth Games. Okay, so different values in the I have put. Now I will see what it will show in mask. Hello, I am participating in the football game, video game, same game, computer game, big game. And what is the predictive value? So you can see that in only 3 lines of code, not only 3 lines of code, only 2 lines, because this line is the package that we are using. Fill mask. This is pipeline. It means pipeline means at backend of this there is RNN, recurrent neural network, and BERT, base uncased. In same way, if you want to see some other thing like the man worked as a mask. Mask means we have to fill this mask. So in only 2-3 lines of code, we can work on Google algorithms. Okay. I am mask professional. Otherwise it will give the and okay. So I have put I am a mask professional. I am a true, medical, real, certified, trained. I am a teacher, masked teacher. So Google will predict it using BERT algorithm. I am a school teacher, good teacher, history teacher, music teacher. And what is the score of that? Coach. Okay, so you can see that how much it is easy. So these I have put in this presentation. So by which way we can work on this. So these are given here in this PPT, each and everything by which way we can use it. In same way, if we want to work on in this way, you can see this. So all of these screenshots I have already taken for demonstration. So you can refer it. Otherwise, these are available on here also. Initially, initially I was okay. Last year I participated in masked game, whatever. Okay, I participated in mask. So it may give me the and then you will see. So in so you can try it. So in 2-3 lines of code, we can work. You can see I participated in volleyball game, in baseball, basketball. Okay. And so what is the basic requirement? Simply we have to implement it. We have to use these models. Okay, these are pre-trained models. Pip install PyTorch transformers. If we are working on a standalone system, if we are working in Google Colab or Kaggle kernels, then we use exclamation sign pip install PyTorch transformers. And different other models can be implemented, can be checked. So it's again face.co, and for example, I want to see Facebook. Facebook models are also available here. So you can see that if I want to implement this, so you can see that this file is available. This particular code is available. I will simply copy this code and I can work on speech recognition, speech analysis. So if I want to create if I'm working on a particular device similar to Alexa, Amazon Fire Stick, so you can see Facebook algorithm. So all of these organizations are giving their code, their deep learning models free. So Amazon, okay, Alexa. So you can see this. Amazon's board. Its citation is also given, and so you can see that it is giving us a reference also. The goal of life is mask. So if I will implement this particular algorithm, it will give me this type of thing. The goal of I want to do space mask next year. So using Amazon algorithm, what it will show. So we can integrate it in our Google Colab. You can see that Amazon board that is used by Fire Stick or Alexa devices. And you can see that how many downloads are there. And we can deploy it. We can train our data. So you can see that I want to do tweet next year. I want to do this. I want to become. Okay, computational time on CPU. And using transformer source code we can see. So you can see that its code is given. So simply copy and paste Amazon board. All of these are transformers. If I want to use Facebook transformers, Facebook BART large, Facebook base. So you can see this WhatsApp medium, Telegram, Signal, and everything is available here on this repository, that is huggingface.co. And its manuals are also available, languages, and all of these are completely free. Microsoft algorithm, input a message. So you can see this input. So if I need to work on a chat application, chat engine, you can see that. Okay, I want to open account. For example, for banking application, I want to create a chat application, chat engine. Okay, so I want to open. So it is giving me this suggestion, this output. I want to open a bank account. Okay, this way. So it gives us some suggestions also. Okay, by which way we can use it using transformers. So Microsoft Dialog GPT large. In same way, these transformers are also available from LinkedIn. So you can see LinkedIn post. Pre-trained models of LinkedIn. Pre-trained models of Facebook, Twitter. All of these we can explore easily. Okay, and I will share this presentation also to all of you, in which you will get the complete details. So currently I'm covering each and everything in dynamic mode, and you can see here it is a particular URL is also available with pre-trained analysis. This is known as explorable transformers. You can see this. So automatically neural network is created, and how many number of layers I want to use, how many layers so what will be the output in 2 layers, in 3 layers, in 5 layers. It will give us the preview of that particular model. So you can see this. What is the weight? What is the prediction? And by which way these are interconnected to each other. So dynamic network formation and its integration. So I will share this PPT to all of you so that you can explore it. And BERT details is also given. And there is another platform that is very, very popular and you should use if you are in deep learning. If you are a researcher in deep learning, then this is very good repository, modelzoo.co. It is having thousands of pre-trained models, not only CNN, RNN, LSTM, everything. If you are working in face recognition, if you are working in MRI, CT scan, ultrasound, satellite images, everything is available. So many pre-trained models are available here, like MRI. So you can see that for MRI, categories, in which category we want to search audio and speech in computer vision. For example, I need some models, pre-trained models in computer vision, and these are for audio speech, TTS, text to speech, neural sequence labeling. Simply click here, and without any coding or in minimum coding, you will be able to work on it. You can see that its code is given, source codes are given in modelzoo.co. It is a repository of thousands of pre-trained models. If I want to see for generative models, so you can see PyTorch, Cycle GAN, Star GAN, directly download it, big data, big GAN. Okay. So you can see PyTorch implementation of generative adversarial networks. So you can see that in few lines of code, we are able to work in only these lines, in using only these lines. In minimum coding, its documentation is also given. How to generate random images, how to generate images from current set of images on model zoom, and in pose estimation. So you can see this facial landmarks. This, so you can see that its code is also given, data set is also given. You can put your own data set, and we can work on very good implementation of deep learning for computer vision, for speech analytics. Okay, and you can subscribe here. Okay, it's better to subscribe such channels, such platforms, so that whenever a new model is given, whenever a new model is released, you will automatically get a mail, and you can use it for your own research work. So using MXNet, we can work on it. Okay, so you can explore it, and now quickly we will discuss another point, that is autoencoders. Quickly we will cover this topic. What is autoencoder? So we will not cover it in so much theory. We will cover it mostly in practicals, in demonstration mode. What is key role of autoencoders? Autoencoder is a specialized implementation in deep learning for pre-processing of data, compression of data, and coding of data, noise removal of data, removal of noise. We want to benchmark a particular data. We want to see, okay, for example, I'm having a particular data set of 5 GB. If I will train that particular model of with 5 GB data set, then implementation will be very, very complex. It will take so many resources. Using encoders, using autoencoders, we can shrink that particular 5 GB data to 5 MB. Shrinking of data. And when we need it back, again it will become of 5 GB. It will be moved to that particular data set in its original way. Many times it happens. For example, we have deployed some drone for traffic monitoring, for surveillance. So definitely, for example, our webcam is having very high resolution, 20 MB images, or each and every image it is capturing, that is of 500 MB or 50 MB, it becomes very difficult to store so many images second wise, so many images. So if we run that for 1 hour, then GBs, terabytes of data will be collected, and definitely it will become very problematic for the data analyst how to fetch the features. Using autoencoders, we can shrink that particular data set. And main application of autoencoder is to pre-process it, to get it in such a way so that it is easily trainable. It can be trained easily without any issues. For dimensionality reduction, in case of traditional machine learning, we work on dimensionality reduction. If we are having high dimensional data, that high dimensional data, so I'm skipping these theoretical points in, I will give you in reference, okay, so that you can analyze it. So to remove the high dimensionality from data set, we use autoencoders. We will see this in practical mode. As far as these points are concerned, base points, I will give it this presentation. Okay, so in autoencoders, for example, I'm having the data set of MNIST. That is very classical data set of images, and we want to use dimensionality reduction. If our data set is high dimensional data, huge data set, and we want to reduce the dimensionality. So you can see that where we are implementing from the, we are coming to that part where encoder is implemented. So you can see here this autoencoder. And its dimensionality, for dimensionality reduction along with autoencoders, we use this particular approach, that is convolutional 2D. Okay, either convolutional 2D network we can use, that is a part of CNN, because in autoencoders are generally implemented in case of images. Okay, because images or videos, computer vision based data set, these are required to be reduced in terms of dimensionality. If you are having high dimensional video, high dimensional images, high dimensional spatial data, for example, we are downloading a data set from ISRO, website of ISRO, from website of NASA. So it will be very, very high dimensional. And if we try to train it, then it becomes very difficult because of higher dimensionality. So to avoid this particular issue, we use encoding, autoencoders. Okay, and you will see that whatever data set. So at backend of this, we are using TensorFlow. So whatever digits we are having, you can see that this is actual data, high dimensional data, and it is reduced. Its dimensionality is reduced. So at the time of training, only this particular data set will be used. And autoencoders are used for, so I'm writing here, autoencoders are used to integrate noise in data so that it will be easy to avoid any type of attack. any type of mishandling of data. For example, if we are using actual data, mishandling of data accidentally or intentional, whether it is intentional updation or accidental updation. So we have manually updated, we have integrated in manual way, so that if any mishandling happens, if any manipulation happens, it can also be handled. Rather than this, you can take your own data set like this. For example, you are having some images, we are having a particular video also, and you might have seen in so many scenarios it is implemented that some particular movie, some particular black and white movie is transformed to colored. Specific a particular song of a movie is taken, it is colored and then again integrated in that video, again inserted in that particular MP4 file. And autoencoders works as the base of generative models. For generative adversarial networks also it is used. Okay, so in this way we can integrate some noise, so that if actual noise happens, if actual noise is there, it can be handled. Okay, so all of these code snippets, so I'm sharing to you. Encoders.py, and I'm creating a zip file, zip folder of all these autoencoders, and this also test data, train, and this. Or this complete folder you can take, no issue. I'm creating a zip of bundle of all these, so that you can work in your systems. Send. So dear participants, if you have any query about these topics that we have covered, RNN, GRU, LSTM, transformers, autoencoders, BERT model, GPT, you can unmute, you can ask your queries, anything if you have to discuss, anything if you want to ask. Meanwhile, I'm sharing this study material to all of you. So dear participants, in openwikisend.com, in download, you will have to write this file ID, and it is a zip file, it is a zip bundle in which you will get source code, presentation, everything I have put in this folder. And kindly confirm, is it downloadable or not, whether you are able to download or not. Presentation source code is uploaded on this URL in this zip. You can unzip it. So in wikisend.com, in download,
Yes, sir, it's visible.
Okay. Is it downloadable, ma'am?
Yes, sir, download.
Okay. So 195.392, you can download presentation code, study material I have put here. And ma'am, we can take queries now. So if participants wish to communicate, they can unmute and discuss.
Yes, dear participants, if you have any query, you can raise your hand or post your queries on the WhatsApp group. Yes, participants, if you have any query, you can ask.
Any query from participants, any query, any question, any doubt, any suggestion, you are most welcome. And whether you have got all these points or not, how much it was easy or difficult, how much these are implementable. Generally, deep learning is considered very difficult. People think that it is very difficult whenever the term came deep. So people get panic with that particular word deep, that there is something in depth. But actually, there is not so much things which are very, very difficult. It is easier than traditional data science, easier than traditional machine learning, because most of the trained models are available. Most of the implementations are available in form of pre-trained models. So you have seen that in 2-3 lines we have implemented Google algorithm for searching. So for any technology, we should not be fearful about the words. Okay, we should move into that technology.
Sir, there is one query on the WhatsApp group. May I ask?
Yes, ma'am, sure.
Sir, how we can create or transform any face or image in animation?
Okay. In animation, first of all, we have to create a sequence of images. Actually, each and every animation is a set of images, sequence of images. Video is working in same way. If we take any MP4 video or any animation in flash file, in shockwave file, so we can fetch a particular sequence. For example, there are 100 frames. 100 frame means 100 images which are running in microseconds. Very quickly these are running one by one. It looks as animation, but actually it is a sequence. So we convert that animation to multiple JPG images, to multiple TIFF images, and then we transform it using computer vision techniques, using image fragmentation, using image colorization. For that, we use OpenCV. OpenCV platform is used, Open Computer Vision, to transform that particular image. Along with OpenCV, we use generative adversarial networks. Okay, so I'm showing you that website, and so this is the official link of OpenCV. It is also completely free and open source, Open Computer Vision, and so many models are available here in OpenCV for image transformation. So OpenCV AI Kit, whether you are getting images or animation from a camera, or you are creating it via some tool like Flash or some other platform. Okay, any other query? Is this clear? So you can explore OpenCV with generative adversarial networks. In OpenCV itself, it can be done.
Okay, thank you very much, sir. So there is one more question. He's asking that what is the use of score in the output?
Score means, in case of BERT, we generally view this type of output. Score means what is the relevance? What is the relevance score? Relevance score means how much it is relevant to the output, how much it is closer to the output. For example, some score is 0.2, other score is 0.19, other score is 0.82. So highest score will be given preference.
So I request once again, if anybody has any query, they can raise your hand. We will give you the mic, or you can ask on the WhatsApp group as well. So one more query is there: how score will be calculated?
Actually, for scoring, the optimizers and functions are already available in Keras. So at backend of Keras, there is TensorFlow, and it is calculated automatically. So whatever optimizer we are using, whatever transfer function we are using, it checks what is the relevance score, what is the relevant output. For example, n number of outputs are there. So with each and every output, its score will be associated. Its relevance value will be integrated.
Okay, I guess, sir, there is no more queries now. So thank you very much, sir. It's really a wonderful session, and thank you very much for sharing your valuable insights about this topic. And I really hope that all the participants have learned something new, and they will definitely use them in their future work and the research work. Thank you very much, sir.
Thank you, ma'am. Thank you to all participants.